welcome to the concepts video on inverse trig functions. So the thing is, we know how to evaluate trig functions such as sine, cosine, tangent, etc. at various angles. If we're given like 30 degrees or pi over 3 or something like that. But what if we wanted to go the other way? It's like, wait, is that even possible? Probably, yes. So what I just said is basically we have trig functions like sine, cosine, and tangent. Okay, these guys all take in an angle, okay, and give us out some value, some like numerical value, right? Okay, what if we wanted to go the other way, right? And whenever we hear, okay, whenever we want to go backwards or the other way or something, we're going to need what's, yes, called an inverse function, right? Because that takes us, it's kind of like a machine that does the opposite operation, okay? So we're going to need some inverse functions, one for each of these guys, right? So, this inverse function is basically going to take in some value and then figure out what angle it was that we had to put in to our sine or cosine or tangent graph, okay? So let's look at these actually. So our sine graph looks like this, where we have, it goes up, down, etc., right? Cosine looks like this, kind of similar, except for we start up and go down and stuff like that. Our tangent graph looks kind of different altogether, right? Because we have these vertical asymptote things, and we go like this, and it's an S, and it just keeps repeating, okay, on some period. So the thing is, if we want to find inverse functions, we need one-to-one functions, right? The ones that pass the vertical line test and the horizontal line test. But all of these functions here obviously don't pass the horizontal line test, right? Because they're periodic, so that means they repeat their output values every period. So these are not one-to-one. So we have a problem. Not one-to-one. And by that I mean that sine, cosine, and tangent, they're all not one-to-one. So what can we do now? We can restrict their domains. Okay? Let me show you how to do this on the next slide. So let's start with the sine graph. So here we have sine theta. Okay, and let me graph it for us. So we want, okay, so here's theta and here's sine, right? And then here's 1 and here's -1 and everything. And let's say here's 1, 2, 3, 4. Okay, 1, 2, 3. Alrighty, so let's say this is pi. This is positive pi over 2, positive pi over 2 here. Here's 2 pi all the way over here. Okay, here's negative pi over 2, negative pi, etc. So our sine graph looks like the following. So it goes up, okay, and then it comes down, goes all the way down, and then comes back up. Okay, and on the other side it goes down like that and goes up like that. Okay, so let me just graph this portion of our sine graph here. Okay, so we have something that looks like this, right? And the thing is, we want to make this one-to-one on a certain interval. Okay, and so we see, well, we could pick this interval right here. I'm going to kind of just make slices, okay, because we see that this section in between negative pi over 2, so in between negative pi over 2 to pi over 2, including those endpoints, we have a one-to-one function. Because let's say we just ignore everything outside of this domain, right? Ignore all of that, and in here we have this segment of our graph, right? And it is one-to-one because it passes the vertical line test, it passes the horizontal line test. So that means that this section here on this domain of our sine graph, this is invertible. Invertible meaning it has an inverse, okay? So let's see a clearer picture on how we're going to find that inverse. So let's say I just draw that one little segment. So here's negative pi over 2, and here's pi over 2, right? And then we had positive 1 up here and negative 1 down here. So this is our normal sine theta graph, okay? And we're just taking that one little segment of it. So it's going to look like this. It goes up like that, and it kind of curves like this, like so, right? So we're taking this guy and we're inverting it, which means that normally the equation that we would have is y is equal to sine theta, right? That's our normal original function, but now we're going to kind of swap the variables. So we get the inverse function of sine. So we're actually going to get theta is equal to sine inverse or inverse sine of y. That's kind of like the equation that we're going to get. So whatever our inverse sine function is, it's going to output an angle to us, okay? And the graph is actually going to look like the following. So the domain for our sine for r's, because we had to restrict the domain, that's going to be negative pi over 2 up to pi over 2. And our output, our range, ranges from negative 1 up to positive 1. Okay? So for our inverse sine graph, this is what we're going to have. The domain and range kind of just switch for inverse functions, right? So our domain is now going to be negative 1 up to 1. Okay, and our range is going to be negative pi over 2 to pi over 2. Okay, so let me label my axes accordingly. So domain goes from negative 1 up to 1, okay? And our range goes from negative pi over 2, so negative pi over 2, up to pi over 2, okay? So we have something that looks like this. And this is like our y-axis, kind of, when you plug in y into our inverse sine. And this is like theta, because you get out an angle, okay? So the inverse of this thing on top, of sine on top, is going to look like this. We're going to have a point down here, a point up here, and it's going to go through 0 again, but now it's going to kind of look a little bit flipped. Okay, so it looks like this. Alrighty, so that's what our inverse sine looks like, and this is also called arc sine. Arc sine is another term for just saying inverse sine. Okay? Now let's work on the cosine graph. So cosine looks like this normally. So we usually have, here's theta, here's our cosine of theta. So cosine theta is up here. Again, we go from negative 1 up to 1 for our range. And then it actually starts up and goes down, so we'll have something, let me graph it out here. So we have, here's pi, here's 2 pi, okay, and here's negative pi. So we start up, we come down, and then go all the way down to negative 1, and then go back up the hill. Right, so we have something that looks like this. Alrighty, and I could always sketch it in the other way as well, like that. Okay, so the thing is, we want to find a domain on which the segment or the function is basically a one-to-one function, and so we can limit it to from here to, let's say, here, right? And we can see if we ignore everything outside of it, like this, then this little segment in here is one-to-one because it passes the vertical line test, it passes the horizontal line test, right? So our new domain, our restricted domain, is going to be 0 to pi, okay? So again, let me draw just this little segment. So cosine theta on this little segment of 0 to pi looks like this. So here's theta, right? And then we're going to go from 0 to pi. So this is 1, negative 1, 1, negative 1, 0 to pi now. So this is pi over 2. Okay, so it's going to start at 0, 1, go down, and end at pi, negative 1. So it looks like this. This is our little segment that we're going to find the inverse of. Okay, so let's identify our domain and range for this one. So for this little segment here, so the domain, the domain on which our cosine is a one-to-one function is 0 to pi, right? And our range is going to be negative 1 to 1. So for our cosine inverse function, our domain should be the opposite. So negative 1 to 1, and then our range is going to be 0 to pi. Okay? So what is our cosine inverse going to look like? So it's actually going to be something like this, where we have our axes like this. Okay, so cosine, so what we had before was that like x is equal to cosine theta. So inversely, we're going to have theta is equal to cosine inverse of x. Okay, so this is like our x-axis, and this is like our theta axis. Okay, so our domain is from negative 1 to 1, so that's going to be on our x, right? And then our range goes from 0 up to pi. Okay, so we have something like that, and our graph is going to look like the following. So we're going to have a point, instead of 0, 1, we're going to have 1, 0, so we're going to have a point here, and instead of pi, negative 1, we just kind of flip those, so we just get negative 1, pi. Okay? Alrighty, and so it goes through like this, and we're going to get a graph that looks kind of like this. Alrighty, so this is going to be our cosine inverse graph, or inverse cosine, whichever way you want to say it, and this is also known as arc cosine. Arc cosine there. Okay, and those are the corresponding domain and ranges of that.